in geometry, we are talking about another type of quadrilateral today that is not a parallelogram, because a trapezoid just doesn't have the same characteristics. We know that all parallelograms have how many pairs of parallel sides? Two. Okay, two. A trapezoid is a quadrilateral, but it only has one pair of parallel sides. Okay? One pair of parallel sides instead of two. So we're moving kind of away from the parallelogram family, still under the quadrilateral section, but a different shape. You probably, when you think of a trapezoid, you probably think of a shape that looks something like this. Okay? And so its pair of parallel sides would be there and there. Those are referred to as the bases. Okay? The bases. And in a trapezoid, if you remember the formula for the area of a trapezoid, you have base 1 plus base 2. Okay? So base 1 and base 2 doesn't really matter which is which, but typically the shorter base is base 1, the longer base is base 2. The bases will never be the same length, because if they were the same length, the only way to connect them is with vertical lines, and now you've got yourself a rectangle, right? So they will never be the same lengths, base 1 and base 2. The legs of the trapezoid, are the sides of it. And the base angles would be the angles at the base of the trapezoid. Okay? I shouldn't mark them with congruency symbols because they're not always going to be congruent. So I'll just shade them in here instead. Okay? So you have the two bases, they'll always be different lengths. You've got the two legs and then the base angles. Another type of trapezoid that you might see looks like this, where one of the legs is vertical. That's okay, because it still fits the characteristics of having parallel bases of different lengths. All right, so you still have your base 1, base 2, top, bottom, the legs on the side, the base angles. One of them just happens to be right. So usually people think of a trapezoid, they think of two diagonal legs. Not necessarily. One of them can be vertical, creating that right angle there, but they can't both be. Otherwise, like I said, you've got yourself a square, rectangle, or whatever. Right? Questions so far? Thrilling. All right. Let's talk about isosceles trapezoids. Okay? And we've talked about that word isosceles before in the context of triangles. So kind of bring that back a little bit. What do you know about isosceles triangles, and what can you kind of predict we're going to be talking about with isosceles trapezoids? Great. Two equal legs. We call them legs here. Okay, it's part of it. What else? Right? So isosceles triangle, you got that two equal sides. So a trapezoid, you have the two congruent legs. What else is going to be congruent? Angle measures, the base angles. Okay, the base angles. So isosceles trapezoid is a trapezoid with congruent legs and base angles. A trapezoid with congruent legs and base angles. And so there are three theorems associated with isosceles trapezoids. Number one starts with the information that if a trapezoid is isosceles, okay? So Theorem 814 starts with the knowledge that if you know a trapezoid is isosceles, then you can conclude, we'll tell, okay. Then the base angles are congruent. Okay. If a trapezoid is isosceles, then the base angles are congruent. So in green, I want to put what we know. And in red, I'm going to draw what we can conclude. So isosceles trapezoid, those two legs being congruent, that's what we know. We can then conclude that the base angles are congruent as well. And I was waffling on how I wanted to write this, but not only are the base angles congruent, but what other pair of angles are congruent? The only other pair, right? They're not called base angles, but the angles at the top are congruent as well. Okay. So knowing it has those congruent legs, then you know that it has the congruent angles. Theorem 815 is really just kind of the converse. It says if the base angles of a trapezoid are congruent, then the trapezoid is isosceles. If the base angles of a trapezoid are congruent, then the trapezoid is isosceles. So we're going to kind of just reverse the colors here. Okay. If we know the base angles are congruent, then we can conclude that the legs are congruent as well. And then, of course, the angles up the top also. Okay. The third theorem, having to do with isosceles trapezoids, has to do with the diagonals. What do you suppose is true about the diagonals of an isosceles trapezoid? Do you know? What do you suppose is true about the diagonals of an isosceles trapezoid? You had to guess. What would you guess? Well, they're congruent. They are. Okay. The diagonals of an isosceles trapezoid are congruent. You ever wonder how shapes get their names? Like, who thinks of trapezoid? You know, all the other shapes like, you know, rectangle, square, they're kind of bland. But trapezoid, I don't know, it's kind of, anyway. Things that keep me up at night. Okay. In an isosceles trapezoid, the diagonals, which there are two of them, just like in all other quadrilaterals, they are congruent. Okay. Questions so far? Now, none of these three things are true for a general trapezoid that is not isosceles. I want to make it clear that these three theorems are only for isosceles trapezoids. Okay? All other trapezoids do have one pair of parallel sides, right? But they will not have congruent base angles. The diagonals will not be congruent. These are only specific to isosceles trapezoids. I want to make that very clear. Okay. Mid-segments. What does a mid-segment do? We've seen that word before in talking about triangles. What is a mid-segment? You forgot, the diagram kind of gives you a hint here. Okay, that segment with labeled 7 is a mid-segment. So what does a mid-segment do? Yeah.
A segment halfway between two lines.
A segment halfway between the two lines. It connects the midpoints of the two sides. Okay. So this segment connects the midpoints of the legs, and that's got the congruency markers there. In a mid-segment of a trapezoid, there are two properties that I want you to walk away with. Number one, it is parallel to the bases. which of course then brings in all sorts of angle relationships, corresponding, consecutive interior, all sorts of things like that. It's parallel to the bases, and its length is equal to half the sum of the bases. A midsegment is equal to half the sum of the bases. As a formula, you could write that it's 1/2 times B1 plus B2. Now, if that looks very familiar as far as that formula for the area of a trapezoid, the only thing that's missing is multiplying by the height. So the midsegment also kind of plays a role in the area of a trapezoid, but it's equal to half the sum of the bases. So to solve for x here, let's kind of plug in what we know. 7 is the length of the mid segment there, and we know that's equal to half the sum of the bases. So 1/2 times 2x plus 10, or 10 plus 2x, either way. Where do you want to go from here? Who's squeaking Squeakerton back there?
It's my chair.
Is there another chair you could use? Thanks, Bubbles. Did you change chairs yet? Yeah. Thank you. Much. Here. Okay, one option is to distribute the 1/2 into parentheses. That would give us half of 2x, which is x, half of 10, which is 5. Then subtract 5 from both sides to get x by itself. We get a value of 2 for x. What would another algebraic option be? 7 equals 1/2 times 2x plus 10. What else could we do here instead of distributing? Algebraically, you have another option. If 7 is half of 2x plus 10, I wrote 2x 10, didn't I? Sorry. If 7 is half of 2x plus 10, what does 2x plus 10 equal? Like, if 7 is half of 2x plus 10, what does 2x plus 10 equal? 14. You could double both sides, because if you're taking half of 2x plus 10 and you double it, that's 2x plus 10. Right? Dividing by a half is the same as multiplying by 2, which would be the opposite operation here. If you solve this, you still end up with x value of 2. So either way is fine. You were kind of taught to distribute, but if you didn't want to go that route, that is another option. Okay? Questions on trapezoids? Their properties. Okay. Your assignment for tomorrow is
You already gave good class.
on page
Joey, can you grab me one?
on page 546.
5 what?
546. 13. Hey, look. I'm still recording. I haven't even sent you off on your way yet. Page 546, 13 to 16. You do need to show your work. Okay. 546, 13 to 16. Work does need to be shown.
What, 546?
546, 13 to 16. Work does need to be shown. This is due tomorrow. That's high math, that's all.